Then infinite discontinuity is what? When your limit is giving you plus minus infinity. You know, limiting value we only consider if it's a finite value, right? If it is giving me infinite, positive or negative infinity, that means you're not, you would say that the limit is not defined. And oscillatory is, for example, let's say sine, similar to jump discontinuity actually. Then infinite discontinuity is what? When your limit is giving you plus minus infinity. You know, limiting value we only consider if it's a finite value, right? If it is giving me infinite, positive or negative infinity, that means you're not, you would say that the limit is not defined. And oscillatory is, for example, let's say sine 1 by x tends to 0 plus, let's say. So this means that this is limit. This is actually what? Sine of 1 by 0 plus. What is 1 by 0 plus? It is infinity. So sine of infinity. Now you know the domain of sine is what? All real numbers. So that means sine infinity, anything very large thing you put in sine, you are definitely going to get a value between -1 to 1 only. So we say that the value is oscillating between -1 and 1. So you cannot determine a specific value. That's when you say that it's oscillatory discontinuity. Make sense?
Yeah.
Okay. Now, if I have to, depict a better way, this is actually your jump discontinuity. This would be your missing point discontinuity, missing point. And finally, this would be your isolated. Point is defined. I mean, some value, functional value is defined at that point, but that point is isolated. Okay, so actually this is written in NCRT. Normally, exam like JEE does not focus on it. They never, ask this. But for a knowledge you should have, like, especially about this and this, because this will come maybe in our solving part, and then we can say that, okay, it's discontinuous, right? Like that. Okay. Now, let's say we can, see for the, let's say, algebra of continuous function. Very important again, algebra of continuous functions. Algebra of limits, algebra of continuous functions, algebra of differential functions, all three are very important. Very useful when you have to speed solve questions. Otherwise, question might look very lengthy, tough and all. Okay, see, let's say f and g are continuous. Tick means continuous, okay? So all of this would be continuous, all of this. Now, can you tell me by very common sense, f by g is continuous, but can you like specify a point, let's say, where this would be discontinuous? And think how discontinuous functions are formed, like for a way to it, for a way it to be discontinuous. So basically, okay, I'll say. So this is of the form some, let's say, polynomial, not polynomial, function by function, right? A rational function we can say, let's say. Now, rational function will be discontinuous when the denominator is not defined. That means this is continuous when f and g both are continuous, provided that g of x should not be 0. Should not be equal to 0. Okay, so if it is for any x for which g of x is 0, those would be the points of discontinuity of that. Otherwise, it would be continuous if f and g are continuous. Now, let's say one is continuous, other is not. So what will happen is these would definitely be discontinuous, and you cannot say anything about these three things, right? Similarly, if this is discontinuous but this is continuous, so discontinuous cannot say anything about this. Cannot say meaning you will have to find, right? You cannot predict. Okay, if both are discontinuous, then actually what happens is you cannot say anything about anything. Okay, so very important table actually. Now, let's say, also just to know, 1 by x looks something like this, right? You know that this is a graph of 1 by x, rectangular hyperbola. Now let's talk about piecewise functions. For piecewise functions, what you have to do is you have to break them. See, we did this in area under curves also. Yeah, you were able to do it very nicely. So keep practicing that. Piecewise functions, you have to begin with breaking it into intervals. There's no other choice, because the function itself is saying that I am a piecewise function. I should be defined for every branch. So let's say they give something like this to you. So, and let's say this is your restricted domain for which you have to check its discontinuity or continuity. So you will break it, right? And do you recall the graph of this? Can you say that, yes, this is discontinuous for x belonging to integers, and otherwise it's continuous, right? So its graph looks something like this. If I have to show you this, like that, right? And for example, for this fractional part of x, it looks like, am I making it correct? Can you tell me?
Yeah.
Yeah. So you can see for integers, the fractional part is obviously 0. And my fractional part lies between what? It lies between It can be 0, but it obviously cannot be 1, right? So 0 to 1. Correct or wrong? Tell me.
Correct.
Okay. Now, this is a method, which is there in our NCRT also, and which we saw in limits also. Let's say you have to evaluate this. You can make the graph and everything, right? But a more algebraic way would be to write this as, since x is tending to 3 minus, so we'll write that as x is 3 minus h. Because 3 minus means what? To the left of 3. So definitely something positive is being subtracted from 3. So that means you will say that, okay, you will replace x with 3 minus h, and now my limit h tends to 0 plus some positive, very small positive quantity. Okay, now tell me one thing. When you subtract a very small positive quantity from 3, it would be something like, let's say 2.99, whose greatest integer is what? 2. So I just want to tell you about this thing, which we already saw in limits also. So comfortable with this?
Yeah.
Okay. Now, this is one question. So can you tell me which of these following functions have non-zero finite number? So that means any finite value, but not 0. Finite number of points of discontinuity. Okay, let me tell you hints. See, this is a tan function. Do you know when is a tan function discontinuous or not defined, at what values? Or if you have to generalize it? Can you say multiples of 5 by 2, or odd multiples, or even multiples, or what?
Or multiples.
Okay, so kind of think about that. Okay, this is a case of rational by rational, right? This also you can see, and this also. Take your time, try. What do you think?
Wait, so the third one is x and then greatest integer
Just
function of x, right? Okay.
Yes.
This, which is separate from the sign one.
Yes. There are 4 options.
Okay. So tan 4x plus 1 will have infinitely many points. So I don't think
Correct.
that's. And
Correct.
mod x minus 1 by x minus 1. That will be non-zero and finite, yeah. It'll have only 1 point, right? It'll be discontinuous at x, so non-zero and finite.
Okay, correct.
The third one will have, okay, other than 0, all the other integers will jump discontinuity, so infinitely many non-zero continuities, so that's not valid. And the fourth one, that's correct, right? Hello, am I?
Yeah.
Okay. And the fourth one is sine pi x, greatest integer function, x square plus 1. Okay, yeah, this is also continuous everything.
Correct. Because
x square plus 1 is always greater than 0, so not 0. And
okay, that is good way of seeing. But can you also see how actually this is a very not a standard, but they have like JEE has asked this a lot of times. See.
Okay, that's also always 0. Yeah.
Correct. Because this is always an integer, and integral multiple of pi, sine is 0. So this is actually 0. Perfect. Also, can you tell me if sine pi this upon x square plus 1 and 0, are they equal functions? The definition for equal function is that domain should be the same, and what else? Range should also be the same. Okay, range should also be the same. So can you see the domain for this is what? All real numbers, right? Range is what? Just 0. For this, can you see the domain? Yeah, this is always defined. You can put anything here as well, right? Put anything, like literally. I mean, all real numbers. So that means
many students practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.